Here we are discussing Edexcel's paper number 2, 2022 Gen paper. Um, so this paper is based on the units energetics, group chemistry, halogenoalkanes and alcohols. So let's see. Uh, an alcohol can be attacked by a nucleophile. Right? So alcohol can be attacked by a nucleophile. So when it comes to nucleophile means nucleophiles like the nucleus, right? So it means it must have a nucleophile must have negative charge, and it is um, attacking the alcohol OH group, right? So to call it a nucleophile, it must have a positive charge. The positive charge is there because of this partial polarity between these polarity at this bond. So near the oxygen, because of high electronegativity, it is partially negative polar. This one is positive polar. So the negative charge can attack this carbon, right? Um, Carbon oxygen bond is weak. This statement is not wrong. This is also correct. But let's go with the other one. Yeah, the bond is weaker, but carbon oxygen bond is polar. Just because this bond is weaker, we can't expect this to attack. There must be a polarity, right? Because it's attacking the positive charge. This is also correct. Oxygen hydrogen bond can form hydrogen bonds. Correct, but not relevant. Oxygen hydrogen bond is polar. That is also correct, but not relevant. Bond is weak, but between these two, the most appropriate answer is polarity, right? Because these mechanisms, nucleophilic, electrophilic mechanisms, are based on the polarities. Right? A student sketch the graph. I'll make it smaller. A student sketched the graph of the temperature K with the decomposition of some of the group 2 nitrates against the metal's atomic number. Temperature with the metallic metal's atomic number. Atomic number is given. A temperature. Decomposition of group 2 nitrates. Right? So when the atom is getting larger, so it means group 2 down the group. When the metal is getting larger, the decomposition temperature is going up also. So it means when the atomic number is going up, the nitrate is becoming thermally stable. Right? So they use the graph to estimate the temperature in centigrades at which the calcium nitrate decomposes. So calcium nitrate, to find that, we have to find the atomic number of calcium. Calcium is what? It is 40, right? So if you can't remember, you can look at the periodic table attached with the paper. So 40, it is what? Uh, right. So as per this graph, it is between uh, right. This atomic number, temperature is given. Right. So atomic number is given here. Calcium is what? Calcium. It is given the atomic number, right? For calcium, Be careful, right? Atomic number is 20. Right? They are not asking about the mass number. Usually we think of the mass number. Atomic number of calcium is 20. So therefore, yes. Uh, yeah, for calcium, atomic number is 20. So 20 means it is around what? What is the answer you got? 587 degrees Celsius. So for calcium atomic number, what is the value of calcium atomic number? What is the atomic number of calcium? 20, right? So 20. So here it is. In Kelvin, around here. Now here they are asking in centigrades. So it is. Uh, so you have 800 in Kelvin. In centigrades, you have to 273 minus 587. Right. So be careful. The one of the easiest question. Here they have given that atomic number. Here they have given it in Kelvin. Right. So if you look at the Kelvin values, then you will end up somewhere else around 860. 860 is not Kelvin. It is they are asking for the centigrade. So you have to subtract 273. So be careful. These are some traps. 20 cubic centimeters of saturated solution of barium nitrate at 80 degrees was cooled to 20 degrees. Right? 20 cubic centimeters of saturated solution of barium nitrate. Barium nitrate saturated. Uh, 20 centigrades, 9.32 grams of crystals were precipitated. Ah, so in the cooling process, it has started to get precipitated, right? The solubility of barium nitrate is 3.74 grams for 100 grams of water at 20 centigrades. What is the solubility of barium nitrate at uh, 80 centigrades in 80 centigrades in grams per 100 grams of water, right? So you are saying 50.3. Okay, let's make and see. Uh, right. So it was cooled. So this amount of crystals were precipitated, right? So what they are mentioned is it's a saturated solution of barium nitrate. So when they cooled it, this amount were precipitated, right? Okay. Right. So now this is given for 20 cubic centimeters. So what they are asking here is what? 100 grams of water, right? So we have to find at 80 degrees centigrades. It is a saturated solution. Saturated solution means uh, now it is saturated. So therefore you will have barium 2 plus ions and nitrate ions. Now remember, uh, with one barium 2 plus ion, there are two nitrate ions, right? So they are asking about solubility. in grams, right? So it's easy. So so this amount is given to 20 centigrade. See, for 100 precipitated, uh, solubility of barium nitrate is 2.73 at 20 centigrades, right? For 100 grams. So therefore, right. So this amount has been precipitated. 9.32 were precipitated. Now what they say is at 20 centigrades, 3.74 were, that is the solubility. So this amount is getting soluble in 100 grams. So in 100 grams, 3.74 are soluble, right? Then we can find in 20 how much are soluble at 20 centigrades. So we are 20 plus 1, 25. So 3.74 over 5 is soluble at 20 centigrades uh, in 20 cubic centimeters, right? Okay. Now this is the amount that has been precipitated, right? Right. So therefore, we had to find amount of barium nitrate which is soluble, right? So uh, so 3.94 plus, right? 3.74. So we have to add them together, right? So this amount has been precipitated once it has been cooled, and already in the solution at 26 centigrade solution, they had this amount of barium nitrate, right? Okay. Solubility of barium nitrate. So therefore, uh, 9.32 they are in the solution. Uh, right. Okay. So we have to add them together. So once you add them together, uh, this amount is given for 3.7, 3.74 is for 100 grams of water plus 9.32 multiplied by 9.32 multiplied by 5, right? 3.74 are already there in the solution, plus 9.32 multiplied by 5. Why? This 9.32 has been precipitated for 20 cubic centimeters, right? So 20 cubic centimeters means 20 grams, but we have to find it for 100 grams. So therefore, we have to multiply it by 5, right? So roughly speaking, uh, 5 times 9 is 45. 45 plus 3 is what? 48. So we haven't considered the point values. So once these point values are added, it is becoming something around 50. So D is the answer. Right? Okay, is that the way you used to find the answer? Good. Let us move on to the next one. What is the flame color produced by strontium? Right? What is the color of strontium? Red color is the, yeah, red color is the color of strontium. Right? Right. Let's move on to the next one. Which order is correct for the solubilities of group 2 sulfates? So when it comes to sulfates, when you go down in the group 2, solubility increase. Solubility is decreasing, right? Solubility decreases down the group. So therefore, the correct order for solubility is barium is less soluble, beryllium, magnesium, calcium, strontium, barium, radium. So, right, barium is at the bottom, beryllium, magnesium, calcium, strontium is here, calcium is here. So in calcium, solubility is much greater, right? This is wrong. This is wrong. Yeah, 5 is the answer is D, right? Yeah. So out of these questions, only trickier one was this one because there you have to be we had to be a bit careful, right? That's it. What is the best solvent for chloroethane? Chloroethane is what? Chloroethane. Chloroethane is a hydrocarbon. Hydrocarbon, organic. So organic is usually dissolved in organic. So, but the thing is, chloroethane means there's bit of polarity. Chloroethane. So there's bit of polarity here, a bit polar. Hexane is non-polar. So two, it is cannot. So non-polar, polar will not be dissolved properly. Hydrochloric acid, no, two polar. Water is very polar. Hexane is less polar. So what? Ethanol is what? It has a medium polarity with a medium polarity. Ethanol will be a better solvent. Molecular mass and the boiling temperature of HF, HCl and HI are shown. Which is the best estimate for the boiling temperature of HBr? Right. Fluorine, chlorine, bromine is right in the middle. Right. Now, as a pattern, boiling temperature has gone down. So we can assume something between this. So, so in that case, we can omit this one. We can omit this one. So it is between this and this. Uh, So minus 20 is not in between value. So part A, yeah, 67 would be a better choice. Okay. Why does hydrogen fluoride not fit the pattern in the boiling temperature uh, of the other hydrogen halides? So hydrogen halide, they are containing hydrogen bonds. Right? These are not just ordinary uh, intermolecular interactions. Right? Permanent dipole interactions are there, but there are a special permanent dipole interaction called hydrogen bondings. So, right. So now this is an anomaly, right? So we are not considering hydrogen fluoride when we are talking the boiling points. It's like here when we photograph, and the other boiling points are going up like this, right? Because of having hydrogen bondings. Hydrogen bond is correct. Yeah, because remember when we are talking about boiling point and melting point. Yeah, boiling point, no, right? What are the factors affecting the boiling point? Intermolecular interactions, right? Intermolecular interaction. So remember, out of intermolecular interaction, there are three types: hydrogen bonding, permanent dipole, ID forces, right? If there are some molecule is having hydrogen bonding, definitely, irrespective of the nature, it is getting the highest boiling point. If there are no hydrogen bondings, we look at the permanent dipole interactions. If there are no permanent dipole interactions, then we can look for ID forces. When we talk for the instantaneous induced intermolecular interactions, we look for the what size of the molecule, right? But remember, we can only look at the ID forces last if it is the only option. But in case if you have hydrogen bonding, you must always pick the one with the hydrogen bonding, right? Because hydrogen bonding is playing a major part in deciding the melting point, right? Okay, so here it is forming hydrogen bonding. So this looks like a correct answer. It is much smaller than the other hydrogen halides. It is correct, but it affects only the formation of ID forces. The other halogens are all electronegative. Uh, all halogens are electronegative, so this is wrong. Fluorine is the most reactive, not relevant, right? Actually, not fluorine is the most reactive, it is hydrogen iodide. This is the most reactive, right? So, as a gas, fluorine is the more reactive, but that is also not deciding on the boiling point and melting points. This is the only answer making sense because hydrogen bondings are playing a major role deciding melting points. If there are no hydrogen bonding, then you can look for other PDPD. If there are no PDPD, you can look for the ID forces. So that is why if you are plotting the graph, hydrogen fluoride melting point is over here. Other melting points are starting to go up like this. An experiment measuring the concentration of the reactant over time period over time produced the graph show time and the concentration. concentration of a reactant over time. Right, so this is about the kinetics. What is the approximate value for the initial rate reaction? So you have, therefore you have to put a line touching here. So maybe my answer is wrong. Let's see whether it is correct. 0 point, it looks like delta y divided by delta x. It's a negative gradient. Uh, right. So anyways, 0.05 divided by 150. 5 times 1, 5 times 3. So looks like 0.0001 divided by 3, 0.000333. Uh, yeah, so 3.3 into 10 to the power of minus. This can't be the answer. So the gradient must be much less than this. So this is not the answer. Gradient cannot be greater than this value. Can't be this. So I feel like uh, yeah. So but we have to find and see. Yeah, but gradient. I think like it's going like this, right? Yeah. Initial one like this. Yeah. In that case, it is 4.5, right? Around 4.5. Be careful. But yes, some because even because you have to start it from over here actually. But I don't like this question much because people can make errors. What are the units for the rate of the reaction? Rate of the reaction is always moles per decimeter per second, right? B. Concentrated sulfuric acid reacts with sodium iodide. What is one role of sulfuric acid? Sodium iodide. Concentrated it is reacting with sodium iodide because in iodine you have I minus. I minus must get oxidized. So in sulfuric in sulfate ions will get reduced. So since iodine is getting oxidized, it is acting as a oxidizing agent, right? A oxidizing agent, correct? Because sulfate is getting is oxidizing I minus. Which equation is not an example of disproportionation? When it comes to disproportionation, same reactant must get oxidized and reduced. So here, this is not a magnesium. Now here, no, this is it the same reactor. Magnesium to magnesium 2 plus. This is a oxidation reduction reaction. Therefore, they are asking which is not an example. So the answer is D. This is disproportionated. This is disproportionated. Copper is disproportionated. Magnesium chloride. Yeah, magnesium is getting oxidized. Hydrogen is getting reduced. So it is not a it's a redox reaction, but not a disproportionation reaction. For the disproportionation, same reactant must get oxidized and reduced. So D is the answer. Which is the displacement reaction that results in a visible color change of solution. Visible color change is to get the production reactants. Uh, Chlorine color is not that visible. Let's leave it later. Iodine is purple, bromine is brown color. Purple to brown color, suspicious. Let's keep it like this. Br to Br minus, I to I minus. Still, it is just a change, but is it visible? Chlorine, fluorine, this is actually not. This fluorine is the colorless gas. This is also a light green color gas. So this can't be an answer. Astatine is a metal. I don't think it's a color. So let's focus on this. Br2, I2. I2 here is what? I2 is not, it's a solid, right? Iodine gas is a solid, purple color solid. But Br2 is what? Getting dissolved and giving the color change, right? So, so between B and C, right? It's a very good done. Yeah, this one will give the major color difference, right? Because Br2 solution is actually becoming colorless, right? Here iodine, yeah. So this is a tricky one. So, but C must be the correct answer, right? But here, let's look at it. This reaction is not happening, right? I2, yeah, iodine cannot displace Br, right? So if this reaction is happening, then there's an issue. But the thing is, between these two, this reaction is not possible. Reaction not possible, right? This reaction is not possible. So therefore, C is the answer here. Right? Otherwise, then there will be a issue because iodine is what? Iodine cannot displace Br because iodine is less electronegative, right? Br is what? More reactive than reactive means Br2 has a greater electronegativity, therefore Br2 can displace iodine. C reaction is possible, B reaction is not possible. A sample of 25 cubic centimeters of 0.204 moles per decimeter sulfuric acid was titrated with sodium hydroxide solution. The titrate obtained was 14.60 cubic centimeters. What is the concentration of sodium hydroxide solution? Right. Titrate was obtained 14.6. Sodium hydroxide solution. So here remember it's a reaction between H2SO4 and sodium hydroxide. It is happening in 2 to 1 ratio. So how much of sulfuric acid has been used? Uh, in 1000 you have 0.205 into 25 cubic centimeters, and remember you have twice the amount of that as sodium hydroxide, 1 to 2 ratio, right? uh, right. So this amount was there. So this is the amount of sulfuric acid in the flask here. So you are using the burette. The burette reading is 14.60, right? In 14.60, twice the amount of moles of sulfuric acid was there in 1000. How much of is there? 1000 to 1000 cancelled off. So definitely, uh, 14.6. So definitely, concentration of sodium hydroxide must be more than the double this amount, right? Why? 1 to 2 ratio, no? So therefore there must be more than twice the concentration of so sulfuric acid in sodium hydroxide, and that amount is also there in 14.6. Here you had that amount in 25. Here you have that in a very less amount. So therefore even more than this, right? So it is 4. So more than this means I haven't done the calculation here. I assume it must be 70872. Right? It must be 702. Understood? Must be a very high concentration than this. That is fine. That is fine. You must have made a small mistake. But so out of these options, this is the answer. Right? I haven't done the simplification. I just assume. What is the percentage error in the type rate? Accurate accurate to 0 0 per reading. Per reading means you have to multiply the absolute error. Multiply it by 2. Yeah, multiply the absolute error. To find the absolute error, you must multiply the minimum reading by 2, right? Because you are making the measurement. Yes, you are doing the measurement 2 times when you are transferring. You do 2 measurements, so 2 errors. So there are 2 absolute errors, right? So the total absolute error is this. Percentage error, so tight they say it is what? Over, this is over 14.6. Be careful to multiply by that 6. Absolute error is made 2 times, right? So it is roughly 14 over 1. 14 over 1 means it is 20. If it is 20, it is 5. If it is so, it must be more than 5. So I look like without doing the calculation 0.68. Yes, 0.68 is the answer. Is it? You multiply this by 100. Calcium carbonate can be heated to produce calcium chloride, calcium oxide. What is the atom economy by mass for the formation of calcium oxide? Atom economy means 56%. Okay, let's see. Atom economy means what we need. Calcium oxide. Calcium is 40 plus 16. Calcium carbonate is what? 100. So 56 is a calculation. What is the concentration in moles per decimeter when 64.5 grams of sodium nitrate is dissolved in water to form 1750 rPm? What is the concentration in moles per decimeter when, okay, let's see, 64.5, right? Now we are divided by what? It is also given 85. 750, then for 1000. 253 times, 250, 4 times. So, roughly speaking, 4 times 1, 4 times 2, right? I assume this to be 1.14 D. Yes. Right here. This is the answer. So I am always doing this calculation by just doing assumptions. The volume of 10 cubic centimeters of magnesium chloride solution was added to an excess of sodium hydroxide solution, forming an precipitate of magnesium hydroxide. After filtering and drying, 0.398 grams of magnesium hydroxide was obtained. What was the concentration of magnesium chloride solution? Let's see, a volume of 10 cubic centimeters of magnesium chloride solution added to excess of sodium hydroxide solution. Okay, excess, forming a precipitate of magnesium hydroxide. After filtering and drying, so very easy one, 3.9398 grams were there in, now divided by 58.3. This is the number of moles of magnesium hydroxide. Magnesium moles in magnesium hydroxide precipitate. Right? So this amount were there in a solution of 10 cubic centimeters. 10 for 100, with 10,000. Right? So, so over divided by t multiplied by 100. So 5 times it is look like 6 times. Let's say it is 60. Uh, so if it is 60, 50 times, 60 times 1, 60 times 0.05. So 5 multiplied by 100.5. So the answer given is what? 0.683. 15 is C the answer? Yes, C is the answer. Okay. Magnesium nitrate decomposes on heating according to the equation given. The 1 mole of magnesium nitrate is completely decomposed. What is the maximum volume of? Okay, let's see. 1 mole of magnesium nitrate. So, maximum volume of gases. So, there are two gases. So, when 1 mole means there are 2 moles, no? So there are, you are making with 2 moles, you can make 5 moles of gases. Then with 1 mole, you can make altogether 2.5 moles of gases, right? Maximum volume means you make the be the subject. Number of moles means 2.5 multiplied by 8.31. Temperature 6K, easy. Pressure is 1 into 10 to the power of 5. So roughly speaking, look at here. You don't need to find the exact value, just make an assumption, estimate. So 2.5 means like quarter. Quarter means it is 150. So 15 times 8. 15 times 4 is 60. 15 times 4 is 60. 15 times 8 is 120. So see the answer? 123 meters. Yeah, C is the answer. So without using any calculator, how I am getting the answer. So don't do it for. I mean, you guys are doing that exam. You have a calculator, but yeah, I can get the answers. What is the percentage yield if 25 grams of magnesium oxide is produced? Uh, right, percentage yield 25 grams. percentage yield means, right? Now remember, uh, expected yield and the yield actually you got 25 grams is the yield you have got it, but expected yield is what? Using 1 mole, you are expecting 2 moles of magnesium oxide, right? With 1 mole, you are expecting 2 moles of magnesium oxide. So 2 into magnesium is 24. 24 plus 16, it is what? 40. So into 100%. So, right. So just start simplified. So it is what? 1 over 2. So it means 2 to 2, let's cancel off. So it is roughly 25%. So let's see something closer to 25%. 31. Uh, is it 31? Yeah. Question number 16. B. A. Let's see. So I made an assumption. 1 mole of magnesium completely decomposed. Similar steps, right? So let's see. Yeah, using yeah, these steps are correct. 25 percentage deal is 25, and the expected deal is ah with 1 mole of magnesium in 1 mole of magnesium. So therefore, yeah, 1 to 1 means right. Ratio is 1 to 1. No, that is also correct. So it must be what? Not two. It must be one, not 2 moles. So 2 moles means then what? Then the value must be uh, 1/4 multiplied by 100. It is roughly not 1/4. 25 or 14. 1/2 multiplied by 100. So it is roughly around with an estimation 50%. So it is 62%, right? It must be 62%. The error we have done here is it says 1 mole of magnesium. So with 1 mole, the yield must also be 1 mole, 1 to 1. Right? The ratio is 2 to 2, no? So must 1 to 1. So we are doing the calculation for 1 mole of magnesium oxide. So it is 140. So we can do an estimation for 50%. So it is 62. So I am always doing this estimation because I am not using a calculator. So you guys have a calculator, you can use it. Since I need to do the calculation fast, only I am doing this, right? Uh, so that is only with the MCQ. So I'll stop the class from here, and we can continue from here next day. Okay, right. Bye.